Hey guys, just going to be moving on with our unit on radicals over here, and next topic is called square root of a function. All right, so what we're doing over here is we're kind of dealing with a new form of almost like a transformation over here. Y equals f of x becomes y equals square root of f of x. So it's not really what we call a transformation, but we do have corresponding mapping notation for this. So if you have a point xy that's on your original graph, y equals f of x, it becomes x comma square root of y. Okay, so this is what the square root of the function is going to do. So the x values stay the same. We square root our y values. All right, so if we're looking at this example one over here, given the function of y equals f of x, sketch the graph of y equals square root of f of x. Okay, first of all, let's start with the domain and range of f of x. Our domain is going to be from negative infinity to infinity, and our range is going to be from negative infinity to infinity. All right, so what's happening here is we're going to list out a table of these 4 points that we have kind of listed here. We have 3, 0, and we have 4, 1, and we have 7, 4, and we have 12, 9. So again, what's happening for this type of transformation? Xy becomes x comma square root of y. So 3, 0 becomes 3, 0. Square root of 0, 0. This point, 4, 1 also stays at 4, 1. So again, the x value stays the same, so 4 doesn't change, but the square root of 1 is 1. For 7, 4, we have 7 comma 2. 12, 9 becomes 12 comma 3. So the graph we're getting here, we have 3, 0, 4, 1, 7, 2, and we have 12, 3. Okay. Now, before I actually go and sketch what this graph looks like, I just want to talk a little pattern here. If you take the square root of 25, the answer is 5. But if I take the square root of 0.25, the square root of that is going to be 0.5. Now, pattern we're looking for here, if I take a number that's bigger than 1 and take the square root of it, the answer can get smaller, become 5. But if I take a number that's smaller than 1, say 0.25, well, 0.5 is actually bigger than 0.25. So the pattern we're looking for, if you have a number in between 0 and 1 and take the square root of it, the answer can get slightly bigger. So if we're looking in between here and here, well, my y values are in between 0 and 1, here and here. So when I'm graphing this guy, this curve is actually going to go slightly above my original line like this, and now it's just going to pass straight through these guys like that. Okay, so what we want to see is like in between 0 and 1 for your y values, your graph is actually going to get slightly bigger, go above it. Okay, hit through this point, and then now it's going to be, now this new curve is going to be below your original function like this. What's my domain and range? Your domain and range of this guy is going to be, my domain is from 3 to infinity. My range is going to be from 0 to infinity. Now, why is it from 0 to infinity? If I look at this point here, I have 2, negative 1. Following this rule, my new point would be 2 comma square root of negative 1. Okay. Now the problem here is like we can't take the square root of a negative number. So for even if my original function has negative y values, my square root function can't exist for those guys over there because we're not going to have any values that are going to work there. Okay, so our range is going to be from 0 to infinity. All right, same idea over here. Given the function f of x, sketch y equals square root of f of x. Now what I'm going to do over here, I'm going to circle a few points like this. Okay, the reason why I'm doing these points is because like these y values are all my perfect squares. So I have like 5, 0, 4, 1, 1, 4, and I have -4, 9. Right? So when I'm doing this, I'm square rooting my y values. Okay, so -4, 9 becomes -4, 3. 1, 4 becomes 1, 2. 4, 1 is going to be invariant, so it's going to stay at 4, 1. And 5, 0 is going to stay invariant as well at 5, 0. So we get invariant, 1, 4 comes down to 1, 2. -4, 9 comes down to -4, 3. And this graph is going to look like this. Okay, we can't take any negative y values and square root those, so the graph does not go any lower than this, and the graph starts over here. Domain and range of my original was from -infinity to infinity, and that was my domain. My range of the original was also -infinity to infinity. My domain of my new function is going to be from -infinity to 5. Okay, biggest x by value is 5, only going to the left. My range goes from 0 to infinity here. Okay, same thing. Given the function of y equals f of x, sketch the graph of y equals square root of f of x. Okay, I'm going to give you a list of steps here to follow. Step 1 should be plot invariant points. All right, so invariant points are going to happen when y equals 0 and y equals 1. Okay, reason is because square root of 0 is 0, square root of 1 is 1. If you take the square root of any other number, okay, well, the answer is going to change. So where does y equal 0? It's going to be my x-intercepts in this case, here and here. Where's y equal to 1? Well, so here's 5, so 1's here. It's going to be here and here. Okay? Plot invariant points. 2, I'm going to say plot nice y values. Now, when I say nice y values, I mean the ones we have that are perfect squares. Okay? So 4 is a nice y value for us. So 4 is happening right here. Square root of 4 comes down to 2. Square root of 4 comes down to 2. 9 is a nice y value. Square root of 9 is 3. Square root of 9 is 3. 16, y value, square root of 16 is 4. So the graph I'm going to get, in between 0 and 1, my curve's going to come slightly above, pass through these points like this, go slightly above through these points like this, and my graph's going to look like that guy there. Okay. Domain and range. My original graph domain was from -infinity to infinity. My range was going from -infinity up to 16. Okay. New function. My new domain is going to go from -4 to +4. So the graph is starting at -4, ends at +4 over here. So there's my domain. My range for this guy, smallest y value I have is 0, biggest y value is 4. My range is going to go from 0 to 4, like that. Okay, example 4. Same idea. Given y equals f of x, sketch y equals square root of f of x. Step 1, where y equals 0. Invariant points here and here. Now where does y equals 1? Here and here. Okay. Step 2, plot your nice y values. 4 is a nice y value because the square root of 4 is 2. So this guy is going to come down to 2. 4 is going to come down to 2 over here as well. 9 is a nice y value because the square root of 9 is 3. Square root of 9 is 3. Okay. Now the graph we're going to get is going to look like this. again, it goes above the curve in this part over here, and now it starts going down below like this, and then it goes like this. Okay. All right. Domain and range of f of x. My original domain was from negative infinity to positive infinity. My range was from negative 1 up to infinity. Okay. New domain and range. My domain is going to be from negative infinity to 2.5. So this point here, combined with 3.5 to positive infinity. Okay. Range is going to be from 0 to infinity, like that. Okay, example 6. So this is tying with some of our transformations as well, talking about our invariant point rules. Okay, so with a variety of transformations that we're going to have, we could have different amounts of invariant points. First question, y equals negative f of x will have blank invariant points, because we're talking about the number of invariant points here, okay? So what this means here is this negative is talking about a reflection in the x-axis. So that means x-intercepts are going to be your invariant points. Well, I have 1, 2 x-intercepts, so I'll have 2 invariant points. Y equals f of negative x will have blank invariant points. Okay, but look at this guy. This is going to be a reflection in the y-axis. So therefore, my y-intercepts here, I only have one of them, will be my invariant point in this case. X equals f at y. Okay, so x equals f at y is going to be an inverse. Okay, and remember, x equals f at y is the same thing as a reflection in the line y equals x. Okay, so y equals x. 1, 1, 2, 2, 3, 3 is this line over here. Negative 1, negative 1 is going to look like this. Now, as you can see, I think we're going to have 2 points. Here is 1 point, and here is 1 point as well. Okay, so when we do our inverse transformation here, we're going to have 2 invariant points. Okay. For our third one, y equals square root f of x. Where do our invariant points happen for square root functions? This was today's topic. This happens when y equals 0 and when y equals 1. Okay, so where does y equal 0? Well, 1 here, 1, 2. Where does y equal 1? Here and here. Okay, so that means we're going to have 4 invariant points for this transformation. Okay, so our answer for this numerical response will be 2, 1, 2, 4. Okay, sorry guys, I know this is definitely kind of stretched out a bit wider over here, but it's kind of tough to fill this page over here. Given the following graphs, so we have f, g, h, and I, we need to match up the square root of each of these functions with one of these graphs over here. Okay, so how are we going to do that? Let's start with this guy over here. Well, how's this graph going to look? Well, we have invariant points here and here, and y equals 1 happens here and here, and this graph should look like this. Okay, so which one of the graphs below looks like this? I'm going to say it's going to be graph 4. Okay, so graph 4 is looking like my graph over here. So for the first one, y equals square root of f of x matches up with graph, I'm going to say, guys, sorry, this is graph 4. That means this was actually graph 8 over here. So y equals square root of f of x matches up with graph 8. Okay. So now our g of x. Okay. G of x, it has no zeros, but it does have a y equals 1, so it's going to be invariant here. When y equals 4, square root of 4 is 2, y equals 4 square root of 2, our graph is going to look something like this. Okay, so which one's that like? I'm going to think this matches up with graph number 5 right here. 5. Y equals square root of h of x. So h of x is here. Step 1, invariant points happen at y equals 0 and when y equals 1. This graph is going to look something like this. And I think this one matches up with graph number 6, 8, 5, 6. And square root of I of x, we have y equals 1 here, y equals 0 here and here. This graph is going to look like this from 0 to 2, which is like this guy over here. So I think this answer should be 8, 5, 6, 7 should be the answer for this question. All right, example 8. The point negative 5, 8 is on the graph y equals f of x. What is the image point on y equals negative 3, f of negative x minus 4 plus 1 minus 2? Okay, this question is quite difficult. We're going to do it with mapping notation. So for the moment here, forget about the square root, and like, what would be the mapping notation for this guy over here? Okay, well, this would be we're putting a negative in front, so it's going to be a negative x, and I'm going 4 to the right. So it's going to be plus 4. Okay, next, I'm taking my y, and I'm adding 1 to it. Okay, so all I've done is look at the part underneath the root sign. I'm dealing with that guy first. Okay, now, what do we know about square root functions? Square root functions square root the y value. Now, this is my y value, so I'm going to square root it like this. If I put a negative 3 in front of my function like this, it means I'm multiplying my y by negative 3, and this minus 2 means I'm shifting the graphic 2 down, so I'm going to have a minus 2 like that. Okay. Now we're going to take this for a point negative 5, 8. Is going to become negative 5 is 5, plus 4 is 9. 8 plus 1 is 9, square root of 9 is 3, times negative 3 is negative 9, minus 2 is negative 11. All right, so this would be the image point for this question over here. All right, guys, I hope this makes sense, and I will see you in the next video.